Hello and welcome to our session titled Intermediate Editing with Focus on UI Customization. Presenters today are one of our editing wizards, Noral Chetsi here on my right, and myself, Thomas Emgem. So let's take a quick look as a little bit of a recap on what is actually available in the editing namespace of the API. So at one point, we have the construction tools allowing us to create new features, and then what we're referring to as sketch tools, where we're modifying existing geometry or attributes. So one is essentially kind of like setting a tool frame or a framework where it ties into editing piece deriving from the map tools. We'll take a look at that closer. And the other piece is kind of like, think of it as the templates that are existing for the Visual Studio environment. So if you're picking, if you're adding a new item to create a construction tool, this template will be stubbed out and kind of like provide you as a quick starting way to facilitate the interaction with the map, as well as get you started on the editing behavior. Another entity is the inspector class. Up until, well, think of the inspector class as a convenience method to modify your geometry as well as your attributes. And it's kind of like, I always kind of say it's kind of like a 50-50 if you're using the inspector class or just going the classic way of the dictionary for the attributes as well as the shapes. But it's gaining certainly much more important, or has gained much more importance with the introduction with the coding access or API access with the annotation feature class. And Narelle is going to show examples for that. We do provide, or the namespace also provides access to the editing templates, what tool are constructed, are the default tools for various types of edits that we would like to do. We have the explicit annotation and dimension feature support that are coming in, and another entity in the namespace is that the usage or the pattern of edit operations, as well as providing the access to the events. So once the features are completed as the raw events, or at the row level features, at the row level events. And we'll talk about that actually on Friday. So that's a quick look. One of the really important pieces, and something that we're really trying to drive home, is the concept of the edit operation. So we kind of like had a little gotcha in the beginning when we put out the documentation, which we now have corrected, is please use edit operations. And for 95 to, I would say, 98% of all actions that you're doing against a workspace, just use the edit operation. I'm not even going to mention the other piece because you shouldn't be using it. But we'll get to that as well. So what does the edit operation itself give you? Well, you can actually encapsulate multiple, you can queue multiple edits in a single operation, and then operate them essentially in one shot. So, and then once you commit your edit operation, they are then participating actually in the undo and redo stack. And you can also have multiple workspaces actually as part of the same edit operation, which is very nice and convenient. And I think the last time I counted, it was something like, and Narelle, please correct me, we have something like 22 methods on the edit operation, and allowing you to create, modify, a lot of things. There's a lot of things on the edit operation. If we're missing something, please do let us know. But yes, I'm trying to emphasize, please use edit operations and use the, as kind of like, as you see down there in the code snippet, use the methods directly that are coming from the edit operation itself. So this being the nucleus, really, let's then actually take a step back and look at, well, what happens when we do want to create a feature. So now then we're talking about the construction tool. And this is pretty much the code snippet or the code that's being stubbed out by the Visual Studio template. We are inheriting from the map tool so that we are getting the interactivity with the screen and can capture that information. So I want to point out here that the sketch type, that's essentially the display feedback as you're interacting with the screen. In this case, we're doing a point, but we have a whole bunch of other geometry types available there to you. So once that sketch is completed, we are overriding the onSketch complete, where we're being handed the geometry. And then we can do additional manipulation to that geometry, or we wrap it around into an edit operation. So we'll give it a name. This is the name that does appear on our undo and redo stack. So that's the label that shows up there. Then we queue the edit and then execute/commit the operation itself. Now, to truly participate in the editor of ArcGIS Pro, we would like to insert our tool into the right component or into the right section of where the system does allow for the create feature in the create feature pane. And for that one, in our tool definition, in our demo file, we're specifying the category, an attribute category ref ID, where we're associating ourselves with the geometry type of the destination feature class. In this case, we're picking construction point. And so on the lower right here, where you see kind of like, as we're tabbing into that feature class, our custom tool now shows up in that location. Other components or categories that are supported are lines and polygons. Probably less used are multi-points, as well as annotations and dimensions. So let's take a look on what that actually is. So here we are in Visual Studio, and it's pretty much fairly, at this point, fairly common or just traditional kind of like, well, we're picking a point, but if we were to actually take a look at the enumeration, we have a lot more to choose from, like a lasso, for example, and so forth. This is, as mentioned, guiding the display feedback that we're getting as we're interacting with the screen. And then we're going ahead. So once then that sketch is complete, we are receiving it as a geometry. In this case, it's a point. However, what we are doing inside the tool is actually we're creating a circle. I mean, we're essentially buffering that point. So with that point coming in, we're constructing a circular arc. And then later on, we're using the arc to construct a polygon, or depending on what our target is, a polyline out of that. And then essentially committing that into an edit operation. So that is kind of like the first little, Didn't know that you could do that. Essentially, even though we're interacting or our feedback type is of type point, we're associating ourselves with the category IDs of a line and a polygon. So here we are saying, okay, for our circle tool, which is our class name, we actually associated that one with the category ref ID of a polyline as well as a polygon. Yet again, using the same class, and then inside our class, we're making the distinction of the template coming in and making an appropriate adjustment to the resulting geometry that we're generating. What it does look like in code, or in Pro is actually, so here we have our sample polygon feature layer in there. So as we are selecting that, here's our tool that now shows up due to the appropriate category ref ID. And as we are then going ahead, we're getting the piece of an interaction of just clicking. Okay, so I already jumped a little bit ahead of kind of like, well, what else is out there? So sometimes there's just, you do want to go just beyond geometry and also collect additional attribution or set up attribute information that will then guide the creation. And for that one, we allow you to specify options. And that options, those do come into play as an embeddable control. That is an existing Visual Studio template. And as you're adding that, essentially it follows the architecture that is being used throughout of ArcGIS Pro, which is the MVVM pattern. So essentially two classes. One is the view model, and then the view itself as the geographic representation of what we're actually then letting the user interact with. Now then there are additional adjustments that we need to make in our descriptive DAML file. So one is essentially for our tool, we're adding a new element called content with the attribute of the tool options ID. So that needs to be a unique ID string. And then in order to associate ourselves, we're actually updating the category of tool options and inserting our ID specified over here in the content. And then as part of the class name, we're pointing into the view model. And then what's actually being presented, so the content, that is just then the essential, the view. Let's do this one more time. So what does that give us? So inside the view model, then we have to essentially implement the iEditing create tool control interface. And this then gives us the appropriate pieces to hook up and initialize our UI components that we would like to present to the user. So the important pieces here are the methods initialize for active template and initialize for template properties. And one of the method argument there is the tool options. And the tool options itself is a collection of key value pairs of information that we would like to store or retrieve in the context of our creation tool. Then the pieces itself of information that we are kind of like getting out of our tool options, we're actually exposing then as properties on our view model, and then binding those into our view. So in this case, the example here is that we're setting the buffer or the radius in our case. We're flagging it as something that that is dirty. So if it doesn't exist yet in our tool options, in our collection, we add it in there. Otherwise, we update the value. And then actually, as part of the MVVN, we actually notify the changes that are then being propagated out through the binding. The actual piece then itself on how we can react on those input informations that are coming to us through the user interface. Let's take a look back on the code in the tool itself. That's then, as here expressed in the Lambda method, that we're retrieving the tool options and getting those properties by name out of it. In this case, we're storing the buffer distance, and then on the sketch complete, we're using that information to modify the creation of our feature. So let's take a look on what that actually means. I believe that's the demo, yes. So as we are let's actually start the debugger. Here's my Chrome. Dum, dum, dum. Okay. So let's actually try something different. Let's select our tool. So by default, we actually see it immediately pops up with our user interface. So this is coming through because in our view model, we actually have one of the properties defined as true. So immediately after, it just comes up as the first entity and gets the attention of the user. If we're setting that to false, we're going directly into the edit mode, but you could tap over into the invoking the custom user interface at that point. So for this example, we're immediately popping it up. And didn't I set a breakpoint? I did. And because I probably made code changes. Let's try that one more time. Oops. Did start? Yes. Let's bring this up, and while this is coming up, let's attention our debugger again. We don't care about this right now. Okay. So at this point, if we're looking at the radius that's being passed in, that's actually 25, and now we're going essentially through the geometry creation itself. So now what actually happens if we just go ahead and say, let's change the value. So at this point, due to the binding, we're actually ending up in the setter method of our property that is bound to the user interface. And at that point, we're going ahead and saying, okay, let's see if we already know about our radius value. Yes, it's already in our tool options collection. Let's update the value and notify the UI of the changes that have happened. Let's go ahead, but I do actually want to do a 45, so we'll go through it one more time.
Can you change that to like lost focus or something like that on the notify, or is it always just on key sequence? Because you got to notify on the 4 and then on the 5.
Mm-hmm.
Is there a way to regulate when that property actually gets changed, or is it always on keystrokes?
You can use the mode and the XAML.
Yeah.
So there's update on property change.
Mm-hmm.
Yeah,
So
in the binding, in the view,
Right.
when you bind on the particular value, there's a couple of options in that binding to specify when that notify property change is going to occur.
Yeah, because that was my question. I assumed there was some XAML or DAML there to actually show that circle radius colon with a text box.
Right, yeah.
Yeah. Okay, so now we're going ahead. And actually, as we're executing, we're now stepping over because I disabled that breakpoint. So let's try this one more time. So that the radius itself, we're actually double checking now and actually retrieving that one as a property from the tool options. So now we're actually stepping into this one, making sure that we have one or that we can retrieve one, otherwise we're using the default. Going ahead and then constructing the geometry with our changed value. And that's the result of this one. And so now we can actually build up your custom user interface as well. Just go ahead and also then adjust the either directly through the template, your default values, or as you're editing, make the changes on those two tabs as part of the construction experience. And that was it for my construction tool.
Is there?
Yeah.
So for this example, it'll work really well. So is there plans for, since you have predefined like radius, displaying that feedback then for like a circle going around with your mouse? So you know that you want a 25-foot radius circle. So in this case, you know that that circle would be going around with your mouse, so that you know when you click it.
So the question is if we are planning to have display feedback for the value, so as we are going around, we see that value as part of that feedback?
Yeah, of that feature.
Of that feature. Back to the wizard.
I don't know that I'm a wizard and I have the correct answer, but I think when you're within your construction tool, you had the sketch geometry type set as point.
Yes.
If you, I believe there's probably a method in there that you could override in terms of changing the sketch geometry and doing some modifications to that sketch geometry so that even though your sketch is a point, what you're going to see in the feedback is actually a circle. I believe you can do that now in terms of modifying the sketch symbol itself. it's not something that we've kind of demoed and have a code snippet out. We can look at possibly building something tomorrow, and if you're interested, you could come by the island and we could talk about it. But I believe modifying the sketch symbol is possible. Might be similar to what I showed you with the annotation, which I'm also going to kind of run through a bit later. But I think you should be able to do something similar. It might have to be on tool activate. Yeah. I'm not sure. I might have to play with it a little bit. It's kind of off the top of my head. Right. It's kind of fuzzy at this time of night.
Okay.
Oh, it's been a long day. Okay, so I'm going to go ahead and talk about sketch tools or the modify tools and how you go and create one of them and use them in the UI and integrate them into the existing modify features pane where all the core editing tools are, or within the favorites gallery through the edit tab. We have a Visual Studio template, which is basically the map tool. And when you use that template, same as any of the other templates, it inserts a C# code file. Occasionally you'll get a view model pair depending upon what you've done, but in this particular instance you get a C# code file and also entries in the DAML file. For the sketch tools in particular, what you're interested in doing probably is integrating them into the modify features pane. So by default, they're just going to sit up on the ribbon for you and you can put them on a tab or it will go on the add-in tab. But for most people, they're interested in putting their particular editing tool into the modify features pane. And you can go ahead and by doing that, by setting this category ref ID attribute. So if you see here, I've just basically used the Visual Studio template to create a map tool. And it gave me all of the stuff by default, an ID, a caption, a class name, and the images and the tooltip. But what I want to do is add my tool into the modify features pane, which you see on the right-hand side. And so but to do that, I set my category ref ID, and it needs to be this Esri editing command list. And then if I want to put it in a particular group, I can add the content tag with the L_group attribute, and I can put some text into that. I can put it in my own custom group. I can put my tool into any of the existing core groups. So if I wanted to put my tool into the alignment group, I can do that. If I want to put it in the topology group, I can do that. If I've written a topology tool. Or you can put it in your own custom group if that's what you want to do. So you can see here, according to what I've got in my DAML file, what you're seeing on the right-hand side is I've got my own little custom group called the Pro SDK samples, and then this is the tool that I've got. One other option for customization is to actually have your tool appear in the favorites. So people can, even though you might have this list of system tools, you also have the concept of people having their favorite editing tools. And generally within the UI, on the Edit tab, we have that tool gallery. And we have it set at displaying 6 tools at the moment. And we have 6 by default in that favorite group. But you can also add your own custom tool into that favorite group by setting the gallery 2D attribute in the content tag. And that's specifically for the favorites in a 2D map. And if you're interested in writing a 3D tool, then you could perhaps set the gallery 3D attribute for your tool to be part of the favorites in a 3D map. By default, these are set to false, so you don't have to specify them. And if you don't specify them, then your tool isn't going to be part of the favorites. But if you want it to be part of the favorites, then you should set that attribute to be true. Similar to the construction tool and being able to add options, user options to your construction tool, you can do a similar thing with the sketch tools. And so the map tool class has 2 properties for being able to specify WPF or UI controls. And the first one is the control ID, which lets you set a DAML ID for an embeddable control. And then the second one is the actual embeddable control property, which lets you retrieve the view model part of your embeddable control. And I'm going to run through an example here and a little bit of how you go ahead and create a basic sketch tool, and then how you extend that to add this embeddable control to get user input. Similar to the way the construction tool went when you create an embeddable control, it updates a specific category in the DAML file, which is the Esri embeddable controls. It gives it an ID and a view model pair. So then within your sketch tool, within the constructor of that sketch tool, you would set the control ID to be the ID of that embeddable control that you entered. And then within some of the properties of your tool, when you're executing within your tool, the thing that you're interested in doing is getting a reference to that embeddable control, casting it to the view model, and then getting that attribute from that view model. You can either do a getter or a setter, it doesn't really matter, it depends on what you're doing within your tool. So let's just jump out to Visual Studio and ArcMap. Sorry, ArcGIS Pro. Bad girl. I think I just got the sack. So what I have here, I have a tab, and I have two tools that have been defined. And if I have a look in the Visual Studio DAML file, you can see that I have the rotate feature and then the advanced rotate feature. And I've added both of these into the Esri editing command list. And I've added them into the My Custom group. Okay, rotate features, I've actually also added into the favorites or the gallery favorites in a 2D map. I haven't done that for the advanced one, so we'll see when we go and look at the favorites in my 2D map that the rotate features is there in the favorites, but the advanced is not. So if we jump back to Pro, they're on my ribbon on my tab, because I also have that in my demo file. But when I go to my modify features, you can see, if we scroll all the way down to the bottom, here's my custom group with my rotate features tool and my advanced rotate features tool. And if I jump to the edit tab and I look at the gallery or the favorites, we do our drop down, we have our favorites here, so here's my rotate features tool, but I don't see my rotate features advanced because I didn't set that flag for that particular tool. But when I scroll down here, this is something new that we did at 2.3 in expanding this gallery drop down to show all of the groups. Again, you'll see that my custom group is down the bottom with the two tools that are registered in that particular group. What else did I want to talk about? So what's my tool doing? Basically, when I look at my rotate feature tool, we're just looking at the standard one. I am a sketch tool. My sketch type is simply a rectangle, and my sketch output mode is map. My sketch complete async, which I filled out. Basically, once I've sketched a rectangle, I'm interested in trying to find the features that are underneath or that intersect with that sketch rectangle. I go ahead and create an edit operation and give it a name. And then I loop through all of that features, the feature set that was intersected. And for each of the features, I'm going to create an inspector object. I'm going to load that particular OID. I'm interested in getting the shape of that feature. In this case, in my map, I've got polylines, so my shape is going to be a polyline. All I'm going to do is find the centroid of that particular feature. I'm going to specify a rotation value in radians, and then using my edit operation, I'm going to call the rotate function, passing in my layer and my OID, the centroid about what I'm going to rotate, and then how many radians I'm going to rotate that feature. So the default tool, the basic tool, is always going to be rotating 45 degrees. I've hard-coded that value in. So if I go ahead and activate this tool and come out, sketch my rectangle, you'll see that my breakpoint goes off. I found all the features underneath that intersect with that particular sketch geometry. I go ahead and do queue up all of the rotations. In this particular instance, it's just going to be the one feature, and execute. And you can see that my feature rotated 45 degrees. If I go ahead and undo, because I used an edit operation, I have something on the undo stack. So I can go redo and undo, and redo and undo to my heart's content. But I did 45 degrees. If I do it a second time, you'll see that I just keep, hopefully, rotating 45 degrees every time. And just keep going and going and going. Sometimes. For the second tool, the advanced, what I'm interested in doing is actually getting the user to give me that rotation value. I don't want to hard code it to be rotating 45 degrees. I want my user to tell me how much to rotate it. So what I have for the advanced tool is actually a UI. And so this is my embeddable control that I've created, which gave me a view and a view model pair. And simply on the view, all I've added is a text block and a text box to get the particular rotation value from my user. So if I quickly jump back into Visual Studio, we can go down and look at the bottom of the demo file. Here's my Esri embeddable control category. Here's the ID that got added when I created a new embeddable control using the Visual Studio template. Here's the view model class, and here's the associated view. Now also, when I created my embeddable control, the Visual Studio template gave me the view and the view model pair. Looking at my view, again, like I said, all I have is a text block with a particular label on it and a text box which binds to a property in my view model. So what I'm wanting from the user is a rotation value in degrees. In my view model, I have my public property, which binds in the XAML, which is my rotation degrees. I also have another public property, which is that rotation value calculated in radians, because that's what my edit operation.rotate value needs. It needs a value in radians. So I've just got another public function on my view model, which is going to do that conversion for me. If I go into my advanced tool, Sketch Complete, you'll see that it's fairly similar to my, my basic tool. The only key thing is that in the constructor, I've set up my control ID to be the ID of my embeddable control. And then on Sketch Complete, I've retrieved my rotate radians from the embeddable control, cast to my view model, calling that particular property. So if I jump in here and type in 33, and then go ahead and run the sketch, again, we'll come into on Sketch Complete. I can see that my embeddable control is got a value. I can see that it's actually of the rotate features options view model type. And then when I get the rotate radians, you can see that I'm 33 degrees in radians, hopefully, whatever that secret number is. And so now when I go through my edit operation, I'm exactly the same as what I was, but instead of having my rotate radians hard-coded to 45 degrees in radians, I'm actually using the value that came out of my embeddable control. So again, I rotate all of the features that intersected with my sketch geometry, queue them all up, and then execute. So again, you can see that I rotated a particular value. I can type a different number in, 90 degrees. Take my breakpoint off. And then we can just keep rotating 90 degrees. Or if I put in 3, sometimes it works, sometimes it doesn't. I don't know why. It doesn't want to work now. But that's the general idea, is that you can, now I don't have any error validation or text validation, so, you know, at this point, somebody can type in DDD or ZZZ. Obviously, if I'm writing a proper construction tool, I would make sure that this particular text box only accepts numerical input. But, you know, in terms of the sample, this is the idea of creating some user interface to obtain input from your user with the sketch tool. So we kind of glossed over the inspector. If you were in my session yesterday, the basic editing session, Sean and I talked a fair amount about the inspector and the edit operation itself. But very quickly, our inspector is our convenient utility class for updating attributes or accessing attributes. And you really just load it up with a particular layer and OID or a layer and OID set. And so you can access any of the attributes or set any of the attributes, including the geometry field, using this inspector paradigm. There's also a way to get schema information about a layer or to be able to copy attributes from new or edited feature. We also have an additional usage of it that we didn't talk about yesterday, but it's its use as an embeddable control. So here's a quick code snippet about how we would use the inspector. You can see that we have the code to create an inspector, and we'll load it up with the selection or the first instance of our selection. We can get the geometry, we can set the geometry, we can set a particular field name with a particular value, and then we create our edit operation. We use the modify method, passing in that inspector, and then execute. Here's my example of using the inspector as an embeddable control. You can see really what it looks like is the top half of the attributes pane or the bottom half of the attributes pane. So in this instance, I've created an inspector. I used the create embeddable control method on the inspector, and that gives me a view and a view model tuple. In the example where I've used this, I basically have another view model which looks at that particular view, puts it in a content presenter, and then when you see on the right-hand side is how that inspector looks as an embeddable control. So it basically lets you load up a particular object and show all of the attributes. I think the sample that we have is kind of like a little flyover. As you fly over a feature, it'll pop up that particular set of attributes, and then when you move off the feature, the embeddable control will disappear if you hover over another one. So it's kind of like the pop-up identifier, except you don't actually have to click. That is available as one of the community samples on the GitHub community samples page if you're interested in looking. Finally, let's have a quick talk about annotation. Again, I talked about this a little bit yesterday, but let's do another review. Annotation is different from the standard feature classes. It is a polygon feature class. It stores polygon geometry, which is the bounding box of the annotation text. This geometry, this polygon geometry, is maintained by the software, so anytime you modify any of the text attributes or the text formatting attributes, that polygon geometry is recalculated by the software. So you as a developer should never interact with this polygon shape. You're interested in acting with the baseline geometry of your annotation text. If you do modify that polygon geometry, the software is actually going to write over your polygon geometry changes. Important things for the annotation is also the label and the symbol classes. These are what gives the annotation its symbolization or its sim-text graphic. Here we have a code snippet from the layer. I can get to the annotation feature class. From the feature class, I use the get definition to get my annotation feature class definition. This is a sim definition. If you were at Charlie's talk this morning where he talked about the sim, you'll know that the sim is something that's really, really important. It gives you lots of fine-grained control. A lot of XML involved. Get used to it. Because sometimes the only way to do the things that you want to do is by using the sim. Anyway, off this particular annotation feature class sim definition, there's two particular functions: get the label class collection and get the symbol class collection, and these are returned as two read-only collections. Like I was saying, the important thing about an annotation is how it's represented, and your basic symbol is by using an annotation class ID and a symbol ID, so one ID from each of those two collections. And these two fields are on the annotation feature class. They are symbol system fields, which means they can't be deleted. Any of the other options that you might want to do overrides on that SimText graphic are not system fields. In 10X, when you created an annotation feature class, things like the text string and the horizontal alignment and the vertical alignment were fields that were defined by the geoprocessing script, and they were system fields. Now when you bring them into ArcGIS Pro and you do a conversion or you create a new annotation feature class, those particular fields are not system fields anymore. They're only optional fields. So even though they might exist in your schema at one particular point, if your user feels like they're going to delete them because they want to, then there's nothing in the software that's going to stop them from deleting them. For this particular reason, we recommend that you don't ever use inspector/field name pattern for any of these text particular attributes. This is why we introduced this Annotation Properties class. So the Annotation Property class has a number of common properties, things that we think people are most likely to want to set: color, font size, horizontal alignment, the text string. If you're interested in getting in deeper into the SimText graphic itself, needing to add leader lines, callouts, shadows, then you use the text graphic property to actually retrieve the SimText graphic, and then you can drill down into the SimText graphic and the SimText symbol and do the things that you need to do at the sim level. We also have a shape property, and this is the shape property that you as a developer are interested in. This is not the polygon shape with the bounding box. This is actually the baseline geometry of the annotation feature. And to complicate it even more for annotation, as if it's not complicated enough, this shape, this baseline geometry, can be a point, it can be a multi-point, it can be a polyline, it could be either a 2-point or a Bezier curve, and it can also be a geometry bag, depending upon whether you have stacked annotation. And you don't know which one it is, really. It could be any of them. So if you're going to do some manipulation of these baseline geometry, you need to kind of cater for the ones that you want to modify and the ones that you don't want to modify, or just accept the fact that there could be more than one geometry type coming through. So, creating annotation. The sample I'm going to show in a minute in Visual Studio is going to be just a simple annotation construction tool. As I said before, annotation class ID and the symbol ID are system fields. They're the two main fields that you need to fill out when you create annotation. And you can either fill them out by using the values that are in the current template, or you can load up an inspector and override those template values and set them from some item that came from the label collection or the symbol collection. So in this particular instance, I have the inspector that's come off of my current template. I've decided to change what those template values are, and so I've got those annotation properties. I've set up a class ID and a symbol ID. I've also changed the text string. I set the shape to be whatever my sketch geometry was coming in. I set those annotation properties back on my inspector, and then I called my edit operation.create using that layer and inspector pair. If you're interested in changing the default values of a template and you're using the inspector, this is the create overload that you want to use for annotation. Normally with a construction tool, the create overload is the template and a geometry. If you want to change those default attributes of the template, you need to use the layer and the inspector overload. Modifying annotation, fairly similar. You create an inspector, you load it up with the layer and the OID, you get the annotation properties, you change one of those annotation properties, you set them back on the inspector, and you use the modify, and then the execute. So a quick jump back into Visual Studio. I have a annotation construction tool. If we quickly have a look here in my DAML file, you can see that I have registered it that I'm going to be creating an annotation geometry type. But when I look at my code, you can see that my sketch type is a geometry of type line. And what I'm actually going to do in my tool activate is, rather than using the template values, I want to change it so that I'm always going to create blue text, and I'm always going to create something that says this is my custom string. And so what I'm doing in the tool activating is getting the inspector from the template, getting the annotation properties from that inspector, setting the ones that I particularly are interested in setting, and then assigning those updated values back to the inspector. And then I can finish doing my tool activation. In my sketch complete, after I've digitized my line, I haven't changed any of this. I'm not going to overwrite any of the default values. So I'm just using the default construction tool stub out of the onSketch complete. So it creates an edit operation, it uses the create, passing in the template and the geometry, and then it calls the execute. So over in ArcGIS Pro, if I jump to my annotation map and I go to the Create Features window, you'll see that I have the standard construction tools for annotation, and then I have my custom tool, which has no tooltip and heading. But when I head and go and activate that, you can see that all of a sudden the text here turned into this is my custom string, because I set that in the tool activate. I overrode the default value. And when I start sketching for my line, you can see that my text color has become blue. And so now, anytime I create something, because I'm using that one tool, I'm always going to be that particular text, even though I won't do this and then go back and activate, it's going to go back and override that particular text, because every time I activate, I'm changing those template properties back. It's not necessarily the world's best example, right? I mean, but it gives you an indication of the types of things that you can do in terms of forcing annotation to be a particular pattern if you're interested in overriding the default symbolization that's set up. Most people would probably change things in the onSketch complete rather than the tool activate, but it's just a different way of showing what you can do. So I think we're just about almost out of time. Luckily, we've just finished. Squeezed it in. So appreciate you hanging around this late at night. There's a number of sessions still tomorrow, obviously. Feature services, utility network, geodatabase. Like Thomas said, we drew the lucky straw and got the early Friday morning session for advanced editing. Would love to see you all here, but completely understand if you're kind of do a bit more celebration on Thursday night with the party or something, or maybe you have to leave anyway, I don't know. We'll be here anyway.
Yes.
There's also the Pro Road Ahead session tomorrow. Looks like all the demo theatres are finished. And please take our survey. Last couple of minutes, any questions? Yes?
So you were saying that to always use the editing, like always use the editing operation. But just a question, I don't know if this is a dumb question, but is it only for map-related operations, or is it also for geodatabase table edits?
Okay, so generally, yeah, that's a really great question. Right now,
What is the question?
Oh, sorry,
For the
what is the
recording.
question? Repeat the question.
Oh, so the question.
No. For
Oh.
me to repeat it so that it's actually use the microphone. What is the question? The question is, using the edit operation, is that really only for layers that are in your project, or how do you use that with tables and things that are actually in a geodatabase that isn't in your map or in your project? Yes, for the most part, the overloads that are on the operation, on the edit operation object, are using the map member and OID combination. Modify, create, delete, split, all of those types of things. They kind of assume that your data is in the map, and so you're using a map member, which is either a layer or a standalone table. If you need to use the Geodatabase API to access external tables, then unfortunately, yes, you are using the Geodatabase API. However, there is one operation, one function on the edit operation, and that is the callback function. And we're going to talk about that in the advanced session, but that is the one.
The only one.
Really the only time you should be using callback, the edit operation.callback function, is to be accessing external tables using the Geodatabase API. Now, the reason for doing that is because you still get in the undo and redo stack, you still have the idea of being within that edit workspace type of environment. There are things coming in the 2.4 API where we've given you a little bit more freedom to use edit operation things using tables and feature classes that aren't actually in the map. So you won't have quite as much need to use the callback when we get to 2.4, but right now using the callback is the way to get kind of the geodatabase external stuff happening. Yeah. Other question? Yes?
So along those same lines, is there a way to prevent an edit operation from going into the undo stack without? So the use case scenario would be you're committing changes to an external database whenever you do an edit in Pro, but you want to keep that transactional nature of being able to roll back if something goes wrong, but not let the user undo the edit operation from the feature class. Because you wouldn't be able to undo it from another external database you've committed to.
Good question.
Repeat the question.
I'm not sure that I can.
So simply,
Yeah. How do
is there
you?
a way to prevent an
Can we exclude it out of the undo and redo stack?
Yeah.
Yeah. I guess, just don't use edit operation.callback. Just directly use the Geodatabase API. And then it kind of just stands out there on its own. And it's not part of that whole edit operation thing. That's the only way I know. I'm not sure whether it works, but that would be the only way I would recommend. Oh, yeah, I mean, I think once you commit it to your database operation, it's committed. And the Geodatabase API doesn't have the concept of undo and redo, right? And that's an editing thing from within the application.
Okay, thanks.
Anything else? Yes?
In a similar vein, if you do some operation that commits to an external system, can you clear the changelog stack so that they cannot undo past that point?
Can you elaborate a little bit more?
So your user goes in, they add a bunch of lines, they do stuff, but then they do some operation that after that point, it's like the point of no return. You don't want them to be able to go back.
Oh, yeah, okay. So how do you clear out that undo?
Yeah.
How do you commit those things? You save edits.
Well, okay.
Yeah, I mean,
And then they
so I
won't
mean,
be able to undo it.
at all, ever, right? Because once you save edits, that's committed and /flushed to the database.
Okay.
So the other way to do it would be to, if you don't necessarily want to save the edits, but you could actually get into the operation manager on that map and clear out the undo stack on that operation manager.
All right, thank you.
You could then programmatically discard those edits too, right? So whilst they may see that they don't have anything on the undo stack, and if you haven't saved edits, then those edits are not necessarily committed. So you're kind of giving them a little bit of a mixed message by clearing that undo stack without necessarily saving those edits for them.
Yeah, it's like
Comes down to what your design of your system is and what you're trying to achieve.
right.
Did you have anything that you wanted
No.
to add to that?
But
No.
it's getting you into this mixed state that you want to be careful with.
Yeah, I can't really think of a use case particularly where you want to do that, but it just seemed like something that I've seen happen somewhere before, so I was just curious
Okay.
how you feel about it.
Yep.
Anything else? No? Well, thanks once again for hanging around late and
Enjoy your evening.
enjoy the rest of your evening. Yes.